so my name is Carson Anderson. I'm here from Domo. I said a lot of people have already seen me many, many times. I have no problems talking. I talk way too much. I always tell people the hardest part is getting me to stop talking. I have a lot of really strong opinions here that are entirely mine, not necessarily of Domo, but let's get into it. Just as a heads up, I'm on GitHub at Carsonoid. That's important because the demo I'm going to run and like a PDF of the slides and a link to the slides is in there. And also all my other talks and everything I always do is always on my GitHub and open source, like every piece of it, down to the SVGs for my really fancy animated nonsense talks. I'm also on Twitter, Carson Ops, and mostly just retweet things smarter people have said. I don't really do a lot there, but I am on it. We're going to talk about Knative and OpenFaaS, right? Since we're at a small group and it's less formal than all the other times, well, most of the other times I've done this, let's take a second before I dive into it and get a feel for where everybody's at and like interest in what parts of this people care about. So, how many people are using Kubernetes in any form? So almost everybody, but a few people that aren't. How many people are using functions of any form as a service? Lambda, okay. So where's everybody at? Is it Lambda? Okay. Any Google Cloud Run? Okay. So the two big ones, anyone using OpenFaaS or Knative? I am, but okay, cool. You should be, because you'll get into why you should be using. I'm trying to be very, very neutral here, but when I get to the end, it'll come out. As we go through, you'll figure out which one I prefer and why I prefer it. But I tried to be very neutral and give it a fair shot here. Also, to give some context about this talk and the whole thing here was born of an actual business decision I had to make, which was we're at Domo, we're doing functions for things already, we're already using OpenFaaS, so that gives you some idea. And then Knative comes out, it's a big hot new thing, and somebody said like, tell me why we shouldn't switch everything that we're doing right now. Whoa. Tell me why we should switch everything that we're doing to Knative, right? Because it's Google and it's got to be perfect and better than this little dinky OpenFaaS thing you're doing. So I did an informal version of this, like just in a document, and I turned it into a presentation. So let's dive in. I'm going to start by talking about Kubernetes and serverless as a concept. And serverless is one of those things that if you ask 20 people what serverless is, you'll get 20 different answers because it's super broad and super vague. But I'm going to take a big statement for everybody that is using Kubernetes and those that aren't, and say that Kubernetes already is serverless. It is a form of serverless. We're already there, right? Like, I don't care for the majority of the time. I don't care about the node that my workload runs on. I might care about groups of nodes and affinity and that kind of stuff. And you might have to care about spreading pods around, but you don't really care about the actual node, right? Like, we don't have a pet nodes anymore. We just have a bunch of nodes. So we already stepped into serverless to some degree. Really, serverless, in my mind, when people ask me, I tell them serverless is a way to reduce your developer complexity. And it's only developer, and I'm both a developer, because if you're going to run your own serverless platform, which you can, and maybe you should, and maybe you shouldn't, it won't necessarily make your ops life easier in certain ways. It does make some things better, but it also gives you a bunch more stuff to be in charge of operationally. But developers really, really love the concept of serverless, maybe not always the actual execution. When we talk about functions as a service, we're saying, specifically I'm talking about functions as a service on top of Kubernetes. We're talking about a way to take a lot of our Kubernetes concepts and simplify and further reduce complexity and scope and blast radius of a bunch of things, right? We're saying instead of have to deploy a bunch of services and link them up and hook them together and figure out how to scale them and deal with all that, I want to kind of like make a bunch of opinionated decisions and abstract that all away and scope down the responsibility of my software, right? It's this classic slide that you've seen 100 times and that I absolutely hate. But we'll go over what it is, and then I'll go why I hate it. This is the one, if you haven't seen it, right, we say, okay, this is our history of software in the last 10 years, where we started with monoliths, and then that had a bunch of benefits. Let's just admit it had a bunch of benefits, but it had problems. And so we said, well, we can't really release a lot. It becomes a big thing to compile and test. So we move it over to services or microservices, and we scope down. We say, now you're responsible for less. I can upgrade you easier. I can test you easier. I can swap it out easier. And then, of course, the logical extreme of that is all the way over to functions, right? It's like instead of saying just a specific service, instead of breaking up service, let's break up to the smallest possible logical unit and put that somewhere, I don't care where, so I can invoke it. And there's a lot of benefits when you go from left to right, and there's a lot of complexity when you go from left to right. Like you're solving some problems, you're creating new ones, but I honestly look at this and I say you could probably be somewhere along the spectrum and have a little bit of everything out there, and that's okay. Like, because certain workloads work better in certain places and certain ones work better in others. Like, not everything should be a function, regardless of what some people say. In fact, I don't know if I'm the best or the worst person to make this presentation, because I'm not on the FaaS solves all your problems bandwagon. I'm on the FaaS solves certain problems really well, but let's not go overboard bandwagon. So before I get into all the Kubernetes stuff, I'm going to come clean and say that Knative is not OpenFaaS. Knative is not Lambda, OpenFaaS is not Lambda. Like, none of the platforms in Kubernetes are Lambda or Google Cloud Run, right? They're not tightly integrated with these platforms. They're not going to be as easy to use if you're already in the platforms. Like, if you're in AWS and you want functions and you're okay with all the various limits and problem and other constraints around Lambda, use Lambda. Like, I'm not here to bash on it. It's just fine. But Lambda is not perfect. Anyone that's tried to use Lambda will, like any managed service, you'll inevitably run into some limits that are more or less arbitrary, right? You have limits on disk size, you have limits on run times. That's a huge one for functions. Lambda runtime is, what, they upped it to 10 minutes recently, but it's still not much. You have all sorts of constraints to have a managed service and get a quality of service. Like, that's the deal with the managed service. So often we look at that and say, well, I hate all those things. I hate the vendor lock-in. Can I run my own FaaS platform, put it everywhere, and make my own rules about what I am going to constrain on so I can do what I need to do? With that being said, I'm going to swap in and retile, and we're going to kind of ground the Kubernetes FaaS platforms again and kind of compare both of them against Lambda. Because I think Lambda's the first big thing out there. It's what a lot of people are using. You're all familiar with it, or a lot of you are familiar with it. So I think it's a good place to kind of look at how giant, highly evolved system works compared to how some of the new Kubernetes ones work. So the plan for today is we're going to introduce all the platforms in case you've not heard of any of them, or all of them. We're going to talk about common components on all of the platforms. Regardless of how different they are, they all have very, very similar kind of groups of components that I can break down and make it easier to compare them to each other. We're going to do a demo, a quick demo to show you how all this works, why you want it, kind of like after we go over all the components, reinvigorate and get you excited about it. Then we're going to compare the 3 different platforms on a bunch of different things. I won't really rename those for you. And we're going to compare how you deal with functions on the platforms, right? So we're going to introduce the platforms, break down the platforms, look at one of them, and then compare them in a bunch of different ways. So let's start with the introduction to all the platform. I want to point out this slide because when you see this slide, immediately after it, you're going to see a head-to-head comparison of each platform for the thing I'm talking about. If you ever get lost about which platform I'm talking about, the icons there will always be in the top left whenever I'm talking about that platform, because there's a lot of subsequent slides for the same thing. So Lambda, let's start by introducing Lambda. There's a bunch of people already using it. It is arguably the first giant FaaS platform out there, right? It was the main big one that kind of got the whole concept started. It's still one of the absolute easiest to use, and there's a ton of benefits with Lambda. I'll get into some of the details. Like, there are a lot of cool things Lambda does, but there's also a lot of lame things about it because it's been around so long. So it's got that like market first benefit, but also all the downsides. OpenFaaS is a really great community-supported, community-driven, entirely open platform for functions, and it is a functions as a service platform like you might expect. Like that, its whole point is to make you deploying functions easy. I really like it because it's super lightweight. The demo we do is in OpenFaaS because it's got the smallest footprint and it's the easiest to get going, and it's full featured. It's the easiest for someone to just start up and start using without having to understand a whole bunch of concepts. Knative is the big new hot Google thing that came out a while ago. It is broadly speaking, it is a serverless platform. It is not a functions as a service platform. It is a huge serverless platform that can be used for functions. It's actually got 3 separate components that you can deploy independently or all together. It's got a building system, a serving system, and this whole function-to-function or serverless-to-serverless eventing system. And you can do all or any part of that. In fact, there are ways to mix Knative's serving system with OpenFaaS's function containers. There's all sorts of, like, it's not completely exclusive with OpenFaaS or any of the other function platforms. But it shows. It's, it is built by Google. It's used to power Google Cloud Run, I've been told, and it when you look at it and work with it, it feels like it's designed to be a giant, huge platform. It's not the easiest to get going, and even the functions are not as easy as a lot of the other platforms, which we'll see when we dig into it. I will also say one big caveat with Knative is that it requires Istio, right? And there are three reactions and three kind of people. When I say this, they're the people that are really super hyped, they're the people that are really super not, and they're the most people which are going, why does that matter? Right? And so in order to explain that, does everybody know Istio service meshes? Okay, I'll go over it real quick for the people that don't, but broadly speaking, a service mesh is this idea that we've got this cool ability to build containers and in Kubernetes land to run multiple containers together inside the same network space. So we have service A, and we use Kubernetes tools to say every time we deploy a service A container, put this Istio or some service mesh solution container next to it. And in Kubernetes land, they share the same network space, meaning I kind of like to think of that Istio container as this wrapper around the other containers in the pod. And we deploy multiple services. They all automatically get that sidecar. They all essentially get wrapped. And when the services talk to each other, all of that communication is intercepted as it leaves the service container and goes into the sidecar container. And that sidecar can do all sorts of really, really cool, fancy things that the service has no idea is happening or may not know how to do. It can do things like mutual TLS, canary deployments. There's a giant list. We'll go over when we get into Knative. And you get a ton of really cool power, and a lot of people really like having this and not having to write it into every service. But it's a heavy lift in your clusters. Like it is inevitably, it's really injecting itself into your networking, and it can be really invasive and be a heavy lift. And we don't run any service meshes anywhere because I just don't want to put up with the footprint of Istio. And you'll see what I mean when we get into installing it. So that's all the platforms. Let's talk about the components in all the platforms. I'll kind of describe them and then we'll go over them one at a time. So every single one of these platforms has some sort of function layer. Obviously, that's what we're here to talk about. They all also have what I call the invoker, because the function layer really just describes what the functions look like. It does not tell you anything about what calls them. They're just dead code. Then, of course, you often send more things into these platforms than they have capacity to run at any moment, so you've got to have some sort of queuing layer. Then you have what I call the ringleader. All these terms, by the way, are completely made up by me. I made them up specifically to not overlap with the actual names of any of the components in any of the platforms, so they tried to keep them neutral. The ringleader is the ringleader because it like manages the circus, right? It's responsible for making new functions, deleting functions, scaling functions. It's your interface layer to the platform. Then they have what I call the usher, which is sort of like the function ingress controller, right? It's the thing that runs the platform and takes all of the inputs coming in to the different functions and routes them to the right place. And you'll see, I'll go into detail about these. But no matter what platform, Lambda, Cloud Run, OpenFaaS, Knative, all the other Kubernetes platforms, they all have this to a degree. So let's talk about functions first, because that's the most important part of these. So function is really, I mean, it's a function. We already talked about the function is the kind of minimal possible logical unit of doing something. There are really two kinds of functions when we talk about functions as service platforms, or two ways of invoking functions, depending on how you want to look at it. There's an imperative function, which is something that it's going to return something you're calling, you're actively calling, and because you want to do something, it's going to do some sort of work, and it's called by an outside system, it's going to return a response, right? It's saying, call this function now. And I'm bringing this up because I really want to split it up from reactive functions, or the kind of reactive calling of functions, because that's the other big part of FaaS platforms, right? So I've got these functions out there in the world. Sometimes I want to call them directly for a result, and sometimes I want to plug them into, say, like S3 or some other event system and say, anytime someone drops any message on a Kafka queue, spin up this function to process that message. And then you may need to spin up 1,000 of those really quick if there's a lot of messages coming in. So they're really, you write the code the same way, but I'm splitting them up in the way you invoke them so that we can talk about the differences when you're handling them in different ways. So let's talk about what functions on all these platforms look like. I went ahead and written this really, really generic function, this boilerplate, not for any platform concept of a get tax function. I didn't want to do hello world. I really hate hello worlds for the most part because they're not useful. So this actually does something, even if it's really naive about it. So the get tax function, no matter where it's going to run, it's going to expect some sort of input of JSON with a subtotal, right? We're going to say, send me a subtotal, or an object with a subtotal or key. I'm going to somehow parse that, and that will change with every platform. Then I'm going to do this really naive tax calculation. just to keep the code small. You can imagine this is a discrete thing that you might do, and it makes sense as a function because you want one place that all that complicated tax calculation logic would go. You probably need to send a lot more than the subtotal. But you can see how this might need to scale really quickly for all your different billing systems. You might want to have single control over what that logic is. So we'll calculate tax in this native way, and then we'll output the tax, and that again depends on the platform. Move that. All right, that's a lot better. Okay, so in Lambda, this function that I've been talking about is pretty simple. Lambda does a lot of really cool helper stuff for you, right? In Lambda, if you want to bootstrap this function, it will kind of boilerplate out a lot of this for you, and it will pre-process the input. I'm not going to cover what the context is. That's a Lambda-specific thing. But our input that we give it when we invoke the function will automatically get parsed, and we can just get the subtotal key out of it and use it. We then do the tax calculation. That doesn't change. And because Lambda functions are often put behind API gateway, you need to return code, right? So it's often put just straight up at the end of an HTTP call. So this is not super complicated to convert this function into running on Lambda. OpenFaaS also has a lot of great helper stuff. So OpenFaaS, we still get this request. The difference is we need to parse the JSON ourselves, which is no big deal. So we parse the JSON ourselves, and we get the subtotal out. Strictly speaking, you can do all of this yourself, but if you kind of just bootstrap a basic Python function with OpenFaaS, this is the rate set is all you really have to write. And then OpenFaaS, at its basis level, handles all input as standard in and all output as standard out. That's how it works. That's how the main invoker for OpenFaaS works. Is you feed a standard in, you put out standard out, which is great because OpenFaaS functions can be the cat command. It can be anything to read from standard in, print standard out, so they can be anything. So we'll just print out the JSON, and we're done. We'll go on to Knative, and I think this is where Knative really starts to show its stripes as being primarily a larger serverless platform. Knative, every function, if you're using Knative to run functions, and you can do all sorts of things with it, but if you're using it to run functions, all the functions need to be full on web servers. That's just the design. There's not a lot of wrapper around that. OpenFaaS and Lambda wrap that web logic for you. Knative says make a web server. So I had to go figure out, I don't really know a lot of Python, so I had to go figure out how do you make a basic web server in Python. You can see the boilerplate is kind of exploded. If I go back, there's like 3 lines of red, 4 lines, and now this is for a super basic function. It's not that much boilerplate, but already I felt like I'm writing more than my function here. I'm running a web server. But at the end of the day, really, you parse the request, you get the JSON, you get the subtotal, and you return the JSON string. Like, that's not terrible. It's just not great. So like I said, really Knative is a broader platform. So that's how functions kind of look in all of these different platforms, and you'll see this working in the demo. Let's move on to the invoker. So far, I've only shown you code. I haven't shown you what calls the code. So all of these platforms have what I call the invoker, and the invoker's job is to somehow live next to or on top of or to the side of the function and fork or otherwise call the function code for you, right? Because we wrote the code, but something needs to call it. It's the one that passes all of the inputs and outputs to the function and kind of interfaces your code with the rest of the platform. It's pretty much always HTTP server or client or both. So it depends on the platform. We'll cover those when we go into each of these for each platform. Invokers matter. Invokers, next to how functions look at a platform, invokers are one of the most important things you should look at if you're picking one, because this is where a lot of the weird decisions that you have to make come from. And a lot of it is not on the face. You kind of have to dig for some of this. And maybe it doesn't matter to you, maybe it does. So when you're picking invoker, you say, when I'm calling my function, do I want it to be synchronous or asynchronous or both? Right? Do I want to call it and wait, or do I want to call it and come back later? Do I want all my function invocations to be serialized into my capacity so that they only go one at a time, or I want to parallelize them and send as many as I have to into the containers at once? This doesn't matter. In Lambda, you don't really control this. Spoiler alert, like Lambda, it's serialized, you have no control over this. But when you're running your own platform in Kubernetes, like you're dealing with your own capacity for your functions. So you have to decide, like, do I let my requests back up while I wait for a container to be open so I can send them through one at a time? Or do I send all the requests in to whatever capacity I have and try to scale it quickly to handle the capacity, which is almost all the Kubernetes platforms, they just let the containers have as much capacity, or handle as many requests as you have at that moment.
we'll come back to that, but you have to ask yourself, like, is it okay if all my function calls share memory and run in a single container at the same time, or do I need them to have isolation from each other? So there's a bunch of these other questions I won't really go over. For me, it was a big deal. For me, at Domo, we're looking at running data imports. We're looking at some very memory and CPU intensive things. And it doesn't matter if in my pod I've reserved 2 CPUs and 2 gigs of memory if I send 1,000 requests into that container at once. Like, that doesn't mean anything to me. For tiny, tiny things, the get tax function, I don't care. Send as much as you have to. Like, it's almost impossible to explode that with resources because it's not doing much. But if you're really heavy in resource utilization, being able to serialize your requests and guarantee isolation and the resource availability, that becomes more important. So just ask yourself those questions about your workload. Let's look at the Invokers for every platform, starting with Lambda. Lambda has this thing called the bootstrap script. You do not have to write this. It comes with all the Lambda kind of bootstrap environments, but you can. They have very, very clear documentation in Lambda that says, here's how you write a bootstrap script. Here's an example written in Bash with curl. Like, it's not a complex system. And the bootstrap script job is to start up, talk to a magic AWS API. I don't know why this keeps cutting out. This is really frustrating. Let's keep moving on. Talk to a magic AWS API, and whenever there's a Lambda invocation event, it calls your function, and then it returns the results, right? That's all its job is really, really straightforward. You can completely replace it, like I said, so if you need to do a lot of special magic and do some connection pool sharing or do some extra setup, you can do that by replacing the bootstrap script. I will also repeat that when you run your functions in Lambda, they are serialized. They're guaranteed that only one at a time runs through that Lambda, not container, but that Lambda VM. And we'll kind of come back to that in a second. In OpenFaaS, you have, hold on, I'm going to just switch. We're not in a hurry here. I'm going to lose my mind. Do you have any questions? Does this all mostly making sense? I know it'll all kind of coalesce together as we get going.
Will you make your slide deck available afterwards?
Oh yeah, it's already available. If you go to my GitHub, you'll get them right now.
Okay, awesome.
Yeah, they're just Google Sheets, so it's.
Go ahead.
Whoa. That's really loud.
Is your one still on?
No, I think. Okay. Man, I hate doing baby stuff. That's even worse. Fine, you win. Machinery. I give. We'll just deal with the one that cuts in and out.
Oh. I noticed that as you move your hand, you hit the kind of side is when it was cutting out. So
You think it's like loose or a cable grab?
yeah, or maybe you put it more in an area where it's really stable.
Okay, I am a big gesticulator.
All right, go back to Invokers. We've talked about the bootstrap script in Lambda. Let's talk about the watchdog or the OF watchdog process in OpenFaaS. So in OpenFaaS, the invoker is completely replaceable, just like in Lambda. Like, this is not a core part. You get to decide how you want to do this. But it comes with one by default, so you, again, don't have to write it if you don't want to. Its job is to be an HTTP client. So the Lambda invoker is an HTTP client, right? It contacts an API and it sends stuff to an API. Same thing with OpenFaaS. Its job is to just sit there and be the web server for you, right? Remember, I didn't have to write any web server code with OpenFaaS, just wrote the main code. So its job is to sit there, and every time it gets a HTTP call in, it will call your code and send you all of the input to standard in, read all of your standard out, and send it back. It's a really, really simple design, but ends up being super, super flexible. In Knative, you've got the Q proxy sidecar, right? So you remember, we've already got in Knative, we've already got an Istio sidecar. We've got our function container, which is a web server. We've got our Istio sidecar over that is intercepting a bunch of network stuff, and then we've got the Q proxy, which is another sidecar that intercepts all of the web traffic. So even though my container is a web server, there's also another layer in front of that doing a lot of the OpenFaaS magic. So its job is kind of sit there, it'll intercept the connections, and then forward the connections down to you. And this is not replaceable. You don't really even have to think about the queue proxy in Knative because you can't do anything about it. Like it's there, it's cool to know that it's there. But unlike Lambda, where I can rewrite the bootstrap to make use of connection pools and be fancy, or OpenFaaS, where I can use a completely different invoker if I want some fancier features, and there are at least 2 of them out there that are official for the project. Knative is like, no, this is going to just sit there. It's there, but don't have to really worry about it. So that's the Invoker Matter platform. They've all got a queuing system. Again, queuing is a really, maybe it's just me, it's really highly specific to me and my workloads, but queuing kind of matters to me what you're doing. So if I send too many requests to, especially to a Kubernetes functions as a service platform, all those requests, if I don't have capacity, they either have to just fill in on the capacity I have or back up. And that's what the queue system is for. It's some places for all the invocations that are either asynchronous, so that you can come back and get the results later, or they're pending, or it's kind of a lot of times it's where the state of these platforms lives. So in all of these, in Lambda, I don't know. Spoiler alert, after this, I don't know anything about what Lambda is doing. I can tell you what the functions work, I can tell you how the invokers work, but that's it. And that's part of the fun and the power, right? Is I don't have to know about anything else about Lambda, but I also can't control anything else. So I assume it's SQS or something, but I don't know. There's some queuing system in Lambda. In OpenFaaS, they didn't write their own queuing system. They use NATS. And if you're unfamiliar with NATS, it's the CNCF kind of Kafka message replacement project, right? It's a message broker, message queuing system. And it's really lightweight, it's really performant, it's really scalable. I think they just had a 2.0 release with a bunch of fancy features. If you're looking at running Kafka, and you're not yet, maybe look at NATS instead. Kafka sucks to run, and NATS is great to run. And their numbers, they posted, I mean, it's their own numbers, admittedly, but their performance numbers are better. So, highly recommend NATS. Yeah, it's a completely separate project, they just make use of it. You'll see that a lot about OpenFaaS. There are the function stuff, but they just reuse a lot of CNCF stuff for monitoring and for queuing. In Knative, there is an in-memory queue for invocations in this queue proxy. So remember our queue proxy invoker that I talked about where it sits and intercepts? If you need to serialize your function calls and you send 10 of them to a container at once, the queue proxy will hold all of those in memory. There is no stable, centralized queue. Meaning that if this container goofs, and you've got 10 things queued up in there, you've got 10 requests moved. Yes?
If I'm getting ahead of myself, then tell me, but I'm a little confused with the Knative. You can obviously have more than one function container servicing a particular function.
Yes.
So how does that scaling happen in conjunction with the queue, which is evidently on a per container basis?
Yeah, so we will cover that a bit when I'll take all these pieces and build each platform with the pieces, but with their details. But yeah, no, you can actually have multiples, but every copy of your function in Knative, so you say I have 10 copies of my function in Knative, you'll have 10 copies of your function and 10 of these containers sitting in front of them. And each of them will have its in-memory queue. Like it's just there's just no queue in Knative. Because they're trying to do a lot of what Lambda's trying to do. They're trying to not deal with queues. They're trying to scale super fast and not have anything ever wait. So yeah, it is literally just in memory, but it's in each of the invokers. So we'll come back and build Knative, and you can tell me if it didn't answer your question when we get to that. So like I said, this is I could be wrong, but in all my research, and if you look at an installation of Knative, you don't see a queue. You don't see NATS. You're not responsible for making a database. You're not responsible for building a Rabbit system or Kafka. And a lot of the other Kubernetes platforms will, like say, we run on Kafka. Like we have this function platform that uses Kafka, and a lot of them are really out in the open. Like here's what our queuing is, and Knative's like, no, the queue is in there. Yeah.
Does that mean that like no going in, there's no guarantees that the function will be called?
I think just Knative just doesn't want you to do queuing. I think they just want you to scale lots of copies of the function real fast. So it is reliable. I don't know. Yeah, it's reliable, but obviously anything never exists. So this is why I read this as a missing thing. Right. Let's move on to the ringleader process because they all have one of those. So the ringleader, like I said, is the kind of the coordinating brain of all the different platforms. It's where you go to do admin things, to make functions, scale functions, delete functions, inspect the system, that kind of stuff. It's the main interface. In Amazon, I don't know, it's basically Amazon itself is the main way that you deal with Lambda functions. Like you don't have some component you are responsible for that manages all your functions in Lambda. In OpenFaaS, it is the very uniquely named OpenFaaS gateway process, and you'll see this in great detail here in a second when we do the demo. But the OpenFaaS gateway process is a lightweight Go process that does a lot. In fact, it does too many things in OpenFaaS if you ask me, but it does a lot of power in there. It hosts an admin gateway, it hosts an API, it's like the main controlling center for OpenFaaS. It's the one piece that kind of makes OpenFaaS what it is. But it, like I said, it's fully open source, it's fully featured, it's a really cool project. In Knative, they have the Knative serving controller. So OpenFaaS, and we'll get into this, but OpenFaaS, you have a lot of ways to deploy it. You can deploy it directly talking to the gateway, you can go to the gateway's GUI, you have options. In Knative, the only way, and this is fine, I'm all on board, the only way you deal with Knative functions is by making Kubernetes resources. That's fine. Like, I love making Kubernetes resources, I love operators, I love custom resources and controllers and all that good stuff. But there's no nice, pretty way to really deal with your Knative functions, right? You've got to write a lot of queue control wrappers or deal with the Kubernetes API right where we're going. So again, it just shows that like there's nothing wrong with this, but it's not really a full like go make functions platform that's super easy to use for everybody. Let's go on to the last piece real quick. The last piece is the Usher. Like I said, it's kind of like the ingress controller for your FaaS platform. So its job is to take all the function requests coming in, route them to the right place, whether that's the right function or a queue or what have you. It's taking all of the traffic coming in. In all the different platforms, starting with Lambda, I don't know, not to deal with it, you can do it through the API gateway, you can use the AWS CLI to invoke Lambda functions. You don't have to deploy this part of the platform. Like again, managed service, there's a lot of power in there. I'm not here to grab on it. OpenFaaS is also the gateway, right? I already said the gateway is overloaded. It does all of the admin stuff. It's also the kind of main router for all your function invocations. So not only do you, and this is fine, it makes it really nice in a lot of respects, but it's not only the way you deploy functions, but it's the way you call functions. So all functions go through it. You can run a lot of gateways. The scales is fine. Like they're stateless, you can run 100 of them. There's no problem with doing this. It's just have multitask on it. Finally, in Knative, they did not write their own way to handle all the function invocations. It's all done through Istio, right? So they said, we don't, Knative doesn't do that. Knative does the building, deploying, eventing, but when it comes to actually calling the functions, that is the Istio ingress job. Whether you're using the official Istio ingress controller or you're using Glue, which is another more lightweight Istio ingress controller. And you get all the service mesh magic with Knative, right? Like this is where a lot of the really cool power comes. You can say, send 5% of my traffic to this new version of function and the other 95% to the existing version. And you can do canary deploys, you can do all that really, really fancy stuff because you have all that Istio goodness if you're willing to put Istio in your cluster. So this is a really, really generic way that this works for all the platforms, right? I'll build every platform with those same images here in a second, but they all kind of look like this to a degree. You can see you're running for a function, for the blue function, we're running multiple of all those things. For the pro function, the same thing, and those scale independently and all that good stuff. But to your point with the queuing, like there's a queue in every single one of those containers. Yeah, I mean, exactly. It has the trade-off not going to another system, but it's also highly ephemeral, right? So I wouldn't use Knative with me. I wouldn't use Knative if I planned on doing a lot of queuing without a lot of scaling to back it up, right? And that's probably what they want. Like Lambda, they just scale super fast on the back end for you so that they keep queuing to a minimum, and same thing with kind of Knative. So let's do the demo. Let's get into like, I know there's a lot of abstract stuff. I promise there's a good reason because it really helps you understand these platforms when we build them, and it helps you make a decision about future ones. But let's like see stuff work and why it's actually cool. So what I've got here, and on my GitHub, so at Harshnoy, there's a talk-knative versus OpenFaaS repo that has a demo in there. You can go get that repo, change it to the demo directory, and if you have Docker and Docker Compose, you run a bash script to bring it up, you run a bash script to do the demo. You don't need, it'll bring up a brand new Kubernetes cluster for you and even show you this exact view, right? Like, I made it as easy as you can to go play with OpenFaaS yourself. The internet's been slow here. Normally I actually create the cluster from scratch in the demo, but I didn't want to have you guys wait while I brought that up. So in the top left here, I've got a view on the OpenFaaS components. So I've got a K3s kind of micro Kubernetes cluster running on my laptop that I brought up from scratch inside Docker. And then we used Helm to bring up OpenFaaS inside that. So all of what makes OpenFaaS work is that first two chunks of resources. It's really it. Like OpenFaaS has a really light footprint for what you get, and it comes out of the box with a GUI, it comes with auto-scaling, it comes with Prometheus, it comes with a bunch of things that just are really easy to get going. I did not have to set any of this up myself. It's literally just me calling the Helm. What I'm going to do here at the bottom is start the demo, and it will type itself because typing on laptop sucks. So we're going to make sure the gateway's up, which we know it is. I'm going to use FaaS CLI, which is OpenFaaS's tool that they gave you that is the only tool you need to work with OpenFaaS. You can use other stuff if you want. You can talk to the API directly, but FaaS CLI has got tons of power, and we'll get into that when I dig more into OpenFaaS. But there we go. I gave it a YAML that described my function, and I can show you that in a second if you want. It is really just like, here's the image, here's where to talk to, and here's the scaling information. And it deployed my function. And you can see, if I scale out, it's really small, but you can at least see that there is a get tax deployment here, and there is a get tax pod. So I said I only need one pod at a minimum. OpenFaaS has scale to 0 out the box, so you can actually say, if I haven't used it in a while, scale to 0 pods, and just scale it up when you need it. Or you can say keep a minimum of n number on hand, right? I'm just got the default, which is keep 1 to a minimum and scale up as needed. So let's actually invoke it here. I hit enter. We're going to use FaaS CLI again to call the function. And you can see, here we go. I echoed in a JSON blob, giving it a subtotal of 100. I pass that into FaaS CLI, which is, again, a nice way to just, if you're doing a lot of dev work yourself, just call your function ad hoc, and it called my function and returned the tax, which is 4.7. It's pretty easy to calculate. Let's do something more interesting. Let's use Vegeta and call this function a lot, like a lot. FaaS, OpenFaaS out of the box comes with auto-scaling. Like I said, it can scale to 0, and it can scale to n number. The default is it's basically waiting for you to ramp up the number of requests that you do, the delta requests over time. So this takes, with the default scaling settings, it takes maybe 20 seconds to start making more pods. But when it does, because I'm calling it so fast, you can see it make a lot of them. So I'll just jump this out one more time. There you go. So it's already started scaling. There you go. It popped up. Meanwhile, Vegeta's like just throwing that same request at it as fast as it absolutely can. And OpenFaaS says, okay, like I'll make more. You suddenly call this function a lot more. I'll make more copies of the function. We'll also see when I control C this that we're going to get a nice little printout of how long it took. So that's not so bad. There, you can see that majority. Well, scroll past it. And actually, before I go, if we wait another 20 seconds, this number is going to go back down to my minimum, right? Because I suddenly had a spike, it's going to scale up to handle that spike, and it's going to scale back down. I will say that because OpenFaaS is parallel invocations by default, when I first kicked off that spam of requests, and I only had one container, all the requests, as fast as they were happening, as many happening at once, were all going into that one container, and it just had to deal with it, right? Because that's the way OpenFaaS works by default, is it just uses the capacity to handle the calls as it can. Once it scales up, it obviously distributes that, but that takes a little while. So that may or may not be a problem. There's ways to work around that. You can see once I stop hitting it, scale back down to 0, and that's all of that auto-scaling is configurable. You can say scale 0, keep n copies. Like I said, you can change the way you scale. You can scale faster or slower, that kind of stuff. The other thing I'm going to do here is I forwarded a connection into the OpenFaaS gateway, right? That gateway, remember I said, it's how you admin, it's what the FaaS CLI is hitting, and it also comes with GUI. So if we bring that up, you can see this is the gateway running in that cluster. You can see my get tax function is already deployed, and I can go see that in 30 seconds or so, I can call it about 4,000 times. And that's just one spammer spamming as fast as it can, and we love those. You can also invoke it directly here. So if I were to go type in my JSON myself, subtotal 100, and I invoke it, there you go. And I can play with this to prove that it's not just returning a static number. I can add more zeros on there, and I can invoke it again, and I can invoke it a bunch of times, and I'm getting my answer back. So this is really cool. This is a nice way to like deal with calling your functions. If you don't want to deal with fast CLI, you can also, of course, use curl, because that's what Vegeta was doing. Vegeta didn't know how to talk fast CLI. It was just curling an endpoint with and sending it JSON. So this is really portable. Anything you can call your functions. There's some other niceties about having this. There's kind of a public store of common functions out there, so you can start playing with some OpenFaaS functions really quickly. I think this, like function browsers, mostly just neat the first time you see it, but you don't end up using it for anything real. But it's nice to go, pull down a new function for getting node info or colorizing images or converting images, that kind of stuff. So that's it. And then you can go ahead and, if you're on this demo yourself, you can exec in the container and play with the functions more, deploy more functions, tear down the whole cluster, that kind of stuff. That just kind of gives you an idea of, I showed you the code that is running the get tags is the exact code that I showed you earlier when we were talking about the get tags function in OpenFaaS, right? It's like minimal information. It was parse the subtotal out, calculate tax, print out the result. Like, I wrote that much code, and deploying it really, once you've got OpenFaaS up, is call a fast CLI and say, I want to deploy this function that's this image and go. And that makes it really easy to kind of add more functions, and if you want to change it, it's all through the fast CLI as well. So hopefully that gives you an idea of what functions are about. It's a really, really simple example, but it's kind of like just one piece of logic. It scaled when I needed it to. I didn't really have to worry about the details of it. There's a lot there that I like. So, like I said, there was only one demo. The reason I'm only demoing OpenFaaS today is it seemed like the easiest, fastest one for everyone to be able to mess with, right? Like OpenFaaS is super lightweight and super easy to get going. I didn't want to demo Lambda because no one can run that without an Amazon account. And I couldn't demo Knative because all the STO injection stuff doesn't work with K8s, which is Rancher's little super mini Kubernetes distribution. So it's not really, and that's not Knative's fault. That's just a reality of how K8s works. So we did our demo, blah, blah, blah. Let's move on to all those components I talked about when I jabbered on about the different pieces. Let's look at how these platforms work and how those pieces connect to each other in the platform. So the architecture of Lambda, the function and the invoker in Lambda both run together. They share the same file system and namespace and all of that inside of a super, super lightweight VM. That's how Lambda works. It runs with this really fancy thing called Firecracker that they open sourced that can start your VMs in some number of nanoseconds. It's supposed to be like real hotness for really lightweight VMs. And it is. Like Lambda runs on it. And there's a lot of Lambda in the world. But it's a VM, which gives you hypervisor isolation, right? Like we trust VMs more than we trust containers still. Like that's just the reality of the world. But it means when I build my functions, I have to package them to run on the operating system that the Lambda VM runs on. I can't just package up my whole thing and give them a container and have portability. I have to go back and understand, like, how did building libraries in Python work? And I have to make a zip file with all my libraries packaged and make sure I use the right ones. And if I'm trying to use native libraries, I can't do it all. Like there are people that do a lot of Lambda that have to have dedicated Lambda build machines that run the same OS as Lambda itself. I don't want to go, I don't know, this is kind of a downside for me. I don't want to go back to VMs to run my functions. I want to continue with containers, or at least container images for portability. As for the rest of Lambda, I don't know. I'll step back one more time. I can tell you that the bootstrap script comes up, talks to the Amazon API, it sends it down to the function, and then it sends it back up to the Amazon API, and that all runs in that VM. As for all of the rest of Lambda, I have no idea. They do not expose that. And so the whole architecture diagram for Lambda is this. Like, the two things I can control, I can tell you about, I can tell you how they run because they tell you that, but that's kind of great, right? Like, there's nothing wrong with this. Other than all of the limits that I've talked about with Lambda, like, yeah, this is all great, but building functions can be weird, and having all sorts of disk limits and runtime limits can be really detrimental. There's more info on Lambda, and again, the slide deck is, I have a link at the end, but there's more info if you're curious about Lambda. I'm not here to bash it, although I kind of have. Next is the OpenFaaS architecture. In OpenFaaS, the function and then the invoker share a container. That's how OpenFaaS works. When you bootstrap an OpenFaaS function, and there are utilities that help you kind of build a Docker and an OpenFaaS function really easily, but it's just going to put your code in there, it's going to inject their watchdog on top of it. And that's fine because it's just a little tiny Go binary, and it doesn't need a lot of stuff. But they share a network space, so technically that's a security problem having them. It makes it hard to limit resources for them independently and give them independent access, but it's not really a big deal. Like I said with OpenFaaS, it's all done through standard in, standard out. So when you send a request in through Kubernetes or through the gateway, like when we were calling that gateway and invoking it, the request came into the watchdog, which is the actual web server. It called my Python script, sent it standard in, and read it standard out. There are other invokers that you can run in OpenFaaS that are more performant and actually do require your function to be a web server. Because forking processes is longer than just sending another HTTP request. That's a reality. But I really like the standard in, standard out behavior. That means there are OpenFaaS functions out there that do transcoding of things because you can send it giant blobs because you're not having to just stream it all in. It's a big, pretty cool. Let's go back. Like I said, the other really big thing that may or may not be important to you, but was important to me, is that all the invocations are parallelized, right? Like, it doesn't matter how much, even though in OpenFaaS you can reserve CPU memory for every copy of your function, it doesn't necessarily help you if a billion copies or a billion current invocations of that function are sharing a container. So most times not a big deal, but it was for me. As far as queuing, remember, OpenFaaS uses NATs for queuing, but it has this other component called the queue worker that you actually saw. In fact, if I pop over real quick, okay, zoom in and highlight it, you can see there's the queue worker right there. There's not much to it, but it has one extra component because it doesn't talk it doesn't necessarily talk directly to NATs. So if we step back, it's the queue worker's job to sit there, watch the NATs queue, watch for new asynchronous things coming in, and then call the function instead of the gateway. Again, I think NATs is really, really cool and scales really well. Yeah?
Is there any notion of chains and affinities in the OpenFaaS model?
I haven't seen it, no. We work around, okay, I'm glad you brought that up. So, chains and affinities, they're working on it, but we work around that by using Kubernetes. Which, if you've been to my Kubernetes talk, we basically say things coming up in the OpenFaaS function namespace, they have certain labels, we put them on a node, we kind of interject that pod and re-contain, because they don't really have, it's really wide open still. Hopefully that's getting better, because that's a lot of like, you want to have those nodes be for functions, not all of the nodes. That may have changed in the last update. The gateway, like I said, is the ringleader. It's the one that we were hitting. You saw us hitting it both with OpenFaaS CLI and hitting the GUI there. It hosts all the things. It's kind of the main way that you get into OpenFaaS and deal with OpenFaaS. It also pulls double duty as the usher. Like I said, it does both things, so I kind of overlaid here because it's doing all of that together. So if you're coming in for admin stuff, you hit the gateway, and the gateway does certain things with Kubernetes. If you're coming in to call functions, if you're calling an asynchronous function, where you're saying, call this, run it when you can, I'll come back and check for the results later, it'll actually drop it into NATs, which then gets pulled out and called. If you're calling it directly synchronously, it sends it straight through to the Kubernetes service and gets your answer. It's not a terribly complex system. That's one of the reasons I like it. It's pretty straightforward. You can look at everything OpenFaaS installs and understand what it's doing, at least to a degree. So this is that like OpenFaaS diagram with all those components. It's pretty straightforward. Let's move on to, oh yeah, I almost forgot. Okay. So OpenFaaS has a cool gateway. It has FaaS CLI, which is awesome, and it has you can deploy your functions that way. But it also optionally, as a separate component, has a FaaS operator. So if you want to, instead of learning a new API and hitting the gateway directly, if you want to just talk to the Kubernetes API and define functions as Kubernetes objects, which we are probably moving to because we already have a ton of tools that talk Kubernetes, and we have 0 tools that talk OpenFaaS API spec. So it's a lot easier to drop more Kubernetes in. You can run the Kubernetes OpenFaaS operator. And you'll make OpenFaaS function definitions in Kubernetes, and the operator will talk to the gateway for you and create them. So then you don't need to learn a new API to create functions, which I think is immensely useful. There's tons and tons and tons of info on OpenFaaS. Alex is the creator. I very, very often find myself at his blog when he's solving weird problems, and he's super vocal on Twitter. It's just became some big cloud CNCF ambassador lately. He's a really smart guy. I met him. He's a nice guy, and he's got lots of information as well as community information on OpenFaaS. Last is Knative. So Knative, remember in Lambda, the function and the invoker in a micro VM, OpenFaaS function and invoker in the same container. Knative, function, and invoker are separate containers. And they can do that because they require all of your functions to be web servers, right? So these are talking over local hosts. They're in a pod. They're sharing the same network namespace. But you get separate containers, which means you get more isolation between the invoker code and your actual function code. So there's benefits to their design for sure. Not necessarily when it comes to writing the functions, but the security model is a lot cleaner. Its job, like I said, is to sit there, intercept all the calls, and then subsequently call your web server from all the calls coming in. So your web server is never directly handling requests from the end user. It also has this really cool thing. As much as the in-memory queuing sucks, the really cool thing about it is in Lambda you have no control about parallelization or serialization of jobs. In OpenFaaS, it's always parallel unless you do asynchronous, and then it's serialized. So it's kind of like if you call it the right way, it'll work the way you want it to work. In Knative, there's a config right there in the declaration of the function that says concurrency model is serialized or parallelized, and when you do a parallel, here's how many can be parallelized at once. So it's explicit and in code, and I really wish this was an OpenFaaS because I don't like that call it the right way and it'll behave the way you want model. So there's one big benefit. The downside being, of course, that if you do serialize and it queues, it's queuing all in memory in every container, which means you could lose messages. So the config is right, but the queuing model is not perfect yet. But kuproxy, like I said, sits there and it's inside of that same container, it's in separate connections, and it just backs up in memory. The ringleader is that controller. So OpenFaaS had the gateway process, or you could use a controller, or both. Knative says, no, we're just doing a controller. That's how we do it with Kubernetes objects only, which is fine. It also, like I said, has ingress, whether you choose to use Istio ingress or Glue. You have to have some sort of Istio ingress controller to handle routing. But you get all those fancy service mesh features, so there's power there. So this is the kind of model of, and it's a simpler model in, there's a few fewer components in Knative, but the actual footprint of Knative is still a lot bigger. So we'll get into that, but that gives you an idea. There's also a ton more information on Knative. I'm not here to bash on it, but it is super clear the more I look at it. And when I really dug into it, like Knative was built for Google to run their thing on and also be open source, so you can maybe use it if you want. But it's not as easy to get going. It's just not as some of the other tools. Let's talk about installing all these platforms. In Lambda, it's two steps, right? Like get an account, get the money, use it. It's really easy, just not always cheap. OpenFaaS, you've got a couple options when it comes to installing OpenFaaS. You can do like I do in the demo, and you can go look at that code. It's a little bash script, and it just calls Helm. And we install all of those 20 OpenFaaS things, or 10, or whatever it was, with Helm. Or they distribute some just raw YAML, right? So we're all kind of more or less comfortable. It's not the best way, but it's still kind of the de facto way. We install Kubernetes things. We get YAML documents, and we keep control applied to the cluster. So you get both of those options with OpenFaaS. I am going to show you the footprint of both OpenFaaS and Knative in Kubernetes because this is something that shocked me when I first looked at it. So here's some of the stuff OpenFaaS makes. I won't go over it in detail, but you could look at it and guess, like, kind of know what all of these things are. It's pretty straightforward. There's one more page on OpenFaaS things, and that's it. Like, this is the OpenFaaS footprint, going back and forth. There's not much to it. It's really, really lightweight, which is really great to me. Yes?
Is that next screening or is next?
That's a good question. It might not persist by default. Yeah, the NAT stuff is something we're going to have to enhance to use it ourselves. Like, it's there, but we're going to have to enhance it to scale based on queue size, which isn't there, and to work with the NAT cluster. But yeah. Knative, before I can talk about installing Knative, let's talk about installing Istio. Because remember, that's required in your cluster. And so if you're not already installing Istio, you have to put it in your cluster. And you have three options if you go to the Knative. If you go through Knative and say, how to install Knative, they'll say, well, to install Knative, first you have to install Istio. And if you want to install Istio, there's these three options. There's a comprehensive, there's a minimal, and there's a custom. And I looked at this, not knowing what I'm doing, and said, well, I don't know what I want. I'm going to do comprehensive, because that's all the things, and I'll have everything. And that's important, because I'm going to show you the footprint for Istio, not Knative, but just Istio. And it comes from that. So technically, I don't need all this stuff, but it is a bit scary when you first see it, right? So you get this first page of Istio stuff, and then you have another page of Istio stuff, and then you have another page of Istio stuff, and it's a lot of stuff. And again, maybe I don't need all that, but it is like, I'm not even installing Knative yet. I'm just getting, and to be fair, once you've got this, you can do it with all your microservices and get all that service mesh magic for a lot of things. But if you just want functions, it can be like kind of this wall to me. Like, oh, you want to use Knative and function? Well, first, install this whole networking solution in your cluster. Now that we've got that and all those things, we can actually install Knative itself. And they said there's no Helm charts, and that's fine. I'm not super fan of Helm anyway. It's just raw YAML. Here's the YAML files, throw it in your cluster, you'll get Knative. When you do that, you get the Knative stuff now. This is on top of the previous things. And there's a couple pages of this. It's not terrible, but it's a bigger footprint. May or may not be a big deal to you, depending on how many clusters you have, how big your clusters are, that kind of stuff. The alternative of all of that, by the way, is to use Glue. If you get GlueCTL, which is this other separate tool, they actually will you can just get that command, have a kubeconfig and say install Knative, and it will put its own minimal version of Istio and Knative in your cluster at once. You won't get the awesome, like one of the really cool things about Knative is that it has a really robust system for hooking up event data sources and event syncs and like triggering functions with each other all over the place. And you don't get that with Glue, but you get a much smaller installation and an easier footprint to use Glue. So just throwing it out there, if you were going to play with it with this. Do not do the other stuff I just showed you. Use Glue, because I think Glue is just a lot easier. So let's talk about building our functions, right? We've shown you the components, we've shown it working. Let's kind of like build a function for these platforms, because we're going to be doing that a lot. That's like the main thing I'm doing with the platform, is building functions. In Lambda, it's a really old school, simple build process, right? I make a directory, I make my function, I do whatever I'm going to do to set up my dependencies, and I build a zip file. And I zip everything up, and I use AWS APIs to upload it to Lambda. That's my distributable. It's a zip file with my code and all of its dependencies, with whatever that tool is for every language. AWS does support out of the box a bunch of different, it's limited, right? Like OpenFaaS supports anything. Like cat can be a function, anything can be a function, because it's just standard in, standard out. Lambda says, well, we're on a specific operating system, so we're kind of restricted on our versions. It's more of a gradual release process. You can't just run whatever. You can make a web server or put it in a container. Like I said before, it uses a lightweight VM for your functions, meaning that if I'm going to build a function, like has anyone tried to do lots and lots of JSON processing in like Python or Ruby or any of those compiled languages, where it's done all in that language, like native to that language, instead of done through a C extension? Like it can be obscenely slow just parsing JSON objects using only Python code. So you'll find, and you may not know, but a lot of your code out there, when you're doing things, you're often calling C extensions or some other extension in a faster language inside your compiled language. And you'll know if you're using those if you go try to use Lambda, because it'll compile on your system, you'll build the dependencies, you'll zip it up and put it in Lambda, and it'll crash because it wasn't compiled for that version of the operating system, because it's not a container. Right? So again, I feel like when I go back to Lambda, I have to relearn like how pip works and how node models work and call Ruby bundle with the right arguments. And I'm not building a reliable distributable container image. I'm building a zip file full of stuff and hope it works. Like this part of it kind of sucks for me. In OpenFaaS, it is much cleaner, freer, and new. You have the fast CLI. You don't have to use it, but it is super helpful. You can bootstrap an entire function. The declaration of the function, the Docker file. Basically, you can say fast CLI, I want a new function using Python called my func, and it will bootstrap a whole directory for you. You go in that directory, and you already have a requirements.txt. So OpenFaaS is, you don't have to do this, but it can really help you along. Really opinion say, well, just put your requirements in requirements.txt, put your code in handler.py, and then use the build command, and it will build the Docker image for you, right? So it wraps a lot of that stuff, and it's giving me an image and not a zip file that I hope works. I'm going to reiterate that the fast CLI tool is awesome. It's got all sorts of things you do. You saw me using it to deploy the function, to invoke the function. It's got helpers for generating new ones and building them and dealing with secrets and all sorts of cool stuff. There's a big list of official OpenFaaS function templates out there. And of course, you can do anything you want, but there's a much bigger list, and it's much less restricted than Lambda because it's in a container and you can do whatever you want. Going to Knative, yes?
In a cluster where you have quotas enabled,
yes.
so you have to specify the resources. How does that work with OpenFaaS and Knative? How do you specify resources?
In OpenFaaS, it's inside the function. When you define the function that you're going to tell OpenFaaS to run this function, one of the things you find is like the image and the entry point, some of those other things. And another is optionally the resources that it's going to have required or reserved and limited in that. Same thing with Knative. There's Knative in its YAML document, Kubernetes has a place where you define those resources. So they kind of just pass that through somehow. They absolutely do work with all of that. When it comes to building functions on Knative, remember I said it has a building system, a serving system, and an event system. You can use this fancy build system. One of the nice things about this big Knative platform is you can say, run the whole Knative platform, and I'm going to hook up the build system to my Git repo. And it will know, and it has all these tools to automatically say, oh, that repo changed, build a new function, canary deploy that function out, and then eventually roll it out or roll it back. Like you can really get a fancy pipeline. And if you go dig into the Google Cloud offering that uses Knative as back, you can see where that can go to the extreme. But it's actually kind of a pain for if you don't have all the fancy pipeline stuff up. It's kind of hard to build and install a function. Like they don't make it. It's not super obvious. It's not as easy as having the fast CLI. You're gonna do this. The fast CLI tends to be a lot easier than trying to do it raw Knative. Like I said, it's really built so you interface with it primarily through Google. And I keep looking over here because I know you're judging me, Nick. Nick's from Google, so I can feel it. That's okay. I have these strong opinions. I'll tell them if anybody says. Yeah, I have honest opinions. Like, well, I mean, like I said, the reality of using it isn't as easy as it should be. But you can of course, build your own Docker image using any tool you want, as long as it's a web server and listens on 8080. That's really like, but it doesn't. There's no helper tool here. It's just build a container that listens on 8080 and run that in Knative. I really like sitting back. I really like having fast CLI to walk me through a lot of this, especially early on. Let's talk about how we deploy the functions on all the different platforms. In Lambda, you have all the AWS methods, right? You have the standard console, CLI, the API. You can do all the different Amazon interaction methods. In OpenFaaS, you saw these in the demo. We have the GUI, we have fast CLI, we have just curling it. This is when we're deploying. So we have the GUI, we have fast CLI, we have the API, or if you run the operator, you can put a Kubernetes resource in. So there's several ways that you could deploy a new function or update a function in OpenFaaS. In Knative, it's simplified, and again, this is fine. And it's just Kubernetes resources. That's how you deploy Knative functions. That's how you update Knative functions, how you delete them. I have no problem with this. It's just not as many options. When it comes to invoking functions, in Lambda, it's almost the same slide as before. You've got all the same Lambda tools to call functions as you do to deploy them. It's the same interfaces. In OpenFaaS, kind of the same thing. You've got that gateway, you've got fast CLI, or you've just got curl. You can get to the gateway pod endpoint, which is what we were doing before. You can just go to /function/the name of your function. That's all it takes. It's really, really simple to call functions in OpenFaaS. In Knative, it's also almost equally simple, except for it's all host-based routing for your functions, right? Like the design of OpenFaaS such is that you get to the gateway, you tell it, I want to call a function, here's the name, the gateway routes you. Knative is more scalable technically because it's more distributed, but you have to get into the cluster and ingress, the Istio ingress controller of the cluster and say, I'm calling you, here's the host that I'm going to, and it translates that to calling a function for you. It's not as easy to kind of ad hoc call, but it's not marketing per se. So we'll do a quick summary of all these, and I'll go over some other platforms real quick. So Lambda, there's screens here, right? There's no overhead. It's all managed for me. Gray area, depending on what you want or need, is the VM runtime. More secure, but also super old school. Limits and lock-in are a huge deal. Most people, when they switch, most people just use one of the cloud offerings when they're doing functions. Like, they do not do what we do, and they did not really dig into these Kubernetes offerings initially. They'll say, Lambda's cool, it's managed, yeah.
I was just going to ask, have you worked with the serverless framework much at all? Because that seems like that creates a lot of wrappers around in this Lambda.
Yeah, I have not. No, I'm just talking about using it raw, right?
Yeah, it used to be called jobs originally, and they rebranded it to serverless.
Yeah, so there are probably a lot. I mean, Lambda is pretty easy to deploy. So you can go in and make a function and edit it entirely in the console and test it. I was just saying at the lowest possible level how it works. But you're right. There are totally ways to make it easier.
Yeah.
And you wouldn't be building zip files manually if you're really doing this at scale.
Yeah, that's what the serverless project was trying to address. So I
Yeah.
just wondered if you dabbled with it.
No, I mean, we do have some functions, but we have a small number of them, and so we don't manage them super well because they don't change much, and there's not many of them.
Sure.
But yeah, you're right. No, and you should use anything else than just making zip files.
Yeah, it seems like the serverless project has a lot of parallels to OpenFaaS.
It's just wrapping Lambda
It's
instead of
using the AWS proprietary environment rather than
an open one. Yeah.
That's an interesting little side that you can actually run OpenFaaS on top of it.
Yes, OpenFaaS kind of gets its hands in there. Like, you can run it inside of Knative, you can run it on Lambda, you can run it on Fargate. Like, it is designed to, like, really the project's goal is to make functions as a service easy, and they don't have a lot, like, Kubernetes is a good way to do it, but they don't have a lot of opinions on just, the original was for Swarm. The Kubernetes integration was later, because they came out with Swarm integration first, so that is another, you're right, OpenFaaS stuff is cool because it's run the way you want to run it kind of stuff. But anyway, so that's Lambda. Most people start there, and then they hit some sort of wall with limits of various things, and that's really when they're like, well, can't get past these limits, I'll do my own thing, right? That's just the reality of it. And you can use it if you want to. Use a manage, use Google's cloud run instead of running Knative yourself. Like, unless you have to, unless you really have to, like, use a managed one, it's a lot easier. OpenFaaS has a lot of greens as well. So I kind of hit on a lot of these. It's super lightweight, everything's cloud native, everything's open source, everything's neutral. It's not owned by Amazon, it's not owned by Google, it's community owned. That means it's not going to get pushed one way or the other. There's a lot to that. And it's free to integrate with all of them freely because it's neutral. It's kind of like social meant for functions. It's got a FaaS CLI. I love the FaaS CLI. I talk about it a lot. It makes it easy, especially if you're just going to play with something for the first time or don't want to build a bunch of tools. Like, it's nice to have one tool that can do end-to-end stuff for my platform. The parallel thing was a huge deal for me, and not having any of the fancy like canary rollouts and automatic fallbacks and functions failing, like it doesn't give you a lot of that kind of higher level function stuff, but it's easy to get going. But you do miss a lot of that stuff you get from Istio. Moving on to Knative, it is this broad serverless platform which you can build huge fancy things, entire cloud offerings on top of. It uses Istio, so you get Istio features, but it also requires Istio, so it can be really heavy to get going and harder to get working in certain situations. There's no persistent queue, and I'm hitting on queuing a lot. We have so much, we do so much data processing and handle so many different requests that are huge, that queuing is a huge deal to me, and it was something that I had to really deeply examine on this platform. So we probably don't care. There's not a lot of helpers, there's not a lot of GUIs, like it's really much like here's the platform, write the sugar around it to make it useful. I'm going to briefly touch on some of the other platforms because there's obviously a lot more than just the two I've talked about, so I'll kind of hit on some positives and notes about all of these. There's OpenWhisk, which requires Kafka, which I didn't really like, but if you really like Kafka, maybe that's a good thing for you. The main thing I really like about OpenWhisk is it is, by default, creates a brand new container for every invocation. Every time you call a function, it spins up a container, calls that function, tears it down. That adds a ton of latency if you're going to run it in Kubernetes raw. So what OpenWhisk does when you run it, and just to also step back, OpenWhisk, if you look into it, has existed long before Kubernetes. It kind of started with containers, and then they inject it into Kubernetes later. So when they say, oh yeah, run OpenFaaS in Kubernetes, it's great. Or sorry, run OpenWhisk in Kubernetes, it's great. If you want good performance, you kind of have to basically say, yeah, OpenWhisk is in Kubernetes, but it's just going to talk to the Docker socket on my nodes directly. Because the latency of creating a pod, waiting for a pod to schedule, and then start is really slow for functions. So I don't know, if you want functions but not in Kubernetes, you want to just spin up some machines and run a function platform that has been around for a while and is performant but doesn't really, if you're not necessarily need Kubernetes, like that might be a good one. Both Kubeless and Fission are imageless. So you define the code you're going to run, and they'll inject that code when they need to run it into running containers. I think that's what they use at Leap. They use Fission. I think they use Fission. And it's nice because you don't have to do anything. There's no build process. You just write the code and you say, this is the function, this is the code, and it sticks it in. Yeah.
How does injection work for binaries?
I have no idea. I asked that same question when they said they support Go, and I never got a good answer. I mean, it obviously makes sense with compile languages. You just stick the code in. I bet not well. With binaries, I bet you it just doesn't work super well. But there, I mean, depending on what your platform is, then you may not be distributing a bunch of Go binaries, it may just be a bunch of Python or Ruby or whatever. It's easy to just inject that code. Iron functions is another one. It's pretty cool because it can just straight up import Lambda functions. So if you're trying to move your Lambda stuff out of Lambda for whatever reason, there's an option that is out there that will just call in and use it as is. There's also FN, which was originally made by Oracle. I didn't super like that it needs a database. They're like, set up this Postgres thing for your functions, and when we have to run a lot of OpenFaaS installations, and having to have a new database every time is not so great. It didn't feel cloud native to me. May not be a big deal to you. The really cool thing about FN is per function, you can say whether or not you want a new container made or whether or not you want to use like a hot pool. Like it's more, a lot of these other platforms say this is how all functions run. And FN said, no, you can actually choose by function whether you need the isolation of a new container or not. So that's it. There's the link right there, like I said, it would be for the demo. So if you want to get the demo for OpenFaaS, it's pretty easy to get going. Like I said, Docker and Docker Compose. There's other stuff that I've done where I talk about Kubernetes and salt and scheduling. And so if you were curious about dealing with, if you're going to use OpenFaaS and you do a lot of functions and you want to deal with complex scheduling in functions, I would look at the dynamic Kubernetes talk, because that's where I talk about Kube, which is Domo's open source project for like scheduling. Yeah.
So what is the typical best practice developing or track down troubleshooting and something goes wrong
in the function?
Yeah. In each platform.
Yeah, every platform is different. I will say Lambda's really good at that. I cannot deny Lambda. If you're going to debug a function Lambda, you can hook it straight up to, you can get tracing, you can get the logs, like all from the console. You can go pull up your code in the Lambda console and be actively developing and running it and invoking it. And that's the best experience. The rest of them, it's kind of build your own debugger, right? Like you can run OpenFaaS locally and like tail the logs and try to send traces out somewhere, but it's not great. It's not. But also the idea is that you're writing this function code that you could call outside of these platforms, right? Because it's going to have pretty well-defined inputs and outputs because it's not supposed to be super large scope. So the functions you're writing should be easy enough to test without needing the platform. Yeah.
With the large section of that is like integration testing. ESTO,
right.
I've seen some groups use it as sort of an integration platform that you like scale, like load testing, and the traffic or simulate traffic. Does Knative take advantage of that at all? Like offer any testing?
I don't think directly. I don't know. He's asking if Knative has any way to like automate integration testing with functions. I know there's Canary deployments, right? And like, did this fail, roll back? But I don't know if there's a way to like leverage some of the fancier Istio features. I'm sure they could because they're in there, but I don't think it does a lot yet.
Have you tested FaaS with like Meetup or anything like that?
Yeah, we're just on Minikube. Yeah, this is on K3s, which is, if it runs on K3s, it'll run on Minikube, right? Because K3s is a lot less.
Yeah, you do the demo.
Yeah, no, it actually works. It's really, the only entry point into OpenFaaS is that gateway. So if you set up, you have to run the gateway, you have to set up a node port or some other ingress rule to get to the gateway on HTTP, and then you can admin and function invocation. So it works really well on Minikube. It's the easiest, it's just, in reality, it's the easiest one to get going.
Is HTTP a hard requirement though for OpenFaaS?
Yeah, that's how you invoke your functions all the time. Yeah, so.
So there's nothing outside of HTTP that like.
Well, I had the same question, so I looked it up. We can call it through HTTP, but there's a bunch of different triggers, which will then make an HTTP call for you.
Right, are you asking about like message queues and stuff?
Yeah.
Oh, yeah. Okay, so the core of OpenFaaS, you're exactly right. The core of OpenFaaS is you hit the gateway with HTTP. But they have a bunch of side projects that say, okay, well, here's an event sync for Kafka, here's an event sync for blah, 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 blah. And it runs in the cluster, and it talks to that thing, but then it does the HTTP request for you. But then you can still call your function based on object stored changes or message queues, right? Like that's, and it's not nearly as robust as Knative. Like OpenFaaS is still, like, it's primarily about invoking functions directly, and optionally you can one of the main things it does really well is calling directly and then calling it asynchronously with a callback, and that callback can be another function. So a lot of the times you say, I hit asynchronously, and then it'll chain down through more functions. Yeah, but like event syncs on message queues and stuff, like it does it, like technically, but Knative is way more robust when it comes to the eventing system.
So I directly support idea or not gRPC.
Not directly, as far as I'm aware. I'm sure you can make a gateway for it, but yeah, no, they all boil down to HTTP because they want you to hit it from just regular web requests. Yeah. Any more questions? So I spent a lot of time staring at these platforms. Yeah.
What was the business decision on
OpenFaaS. OpenFaaS everywhere. If you know anything about Domo and our situation, we're up to 15 clusters, and that's probably going to just go 50% more in the next 6 months because we have a lot of bubbles, lots of bubbles. And doing that, the smaller the footprint of the platform, the better, right? The main thing we're going to solve, like I said, is queuing. We're going to really have to solve how we're going to handle queuing with OpenFaaS, because we need to serialize everything by default and scale, not based on how many more calls we're getting into the function, but how big that queue is. So it's not perfect for us out of the box, but it's just a lot of lightweight. Yeah.
So I missed your breakdown, but you said that ISTIO is a hard requirement for Knative.
It is.
But what are your ingress options with OpenFaaS?
It's so you can hit the gateway directly, and it serves HTTP requests, or you can put an ingress controller in front of it.
Okay.
But it's really just like the one entry.
So you can basically choose your own ingress controller with OpenFaaS.
Yeah, exactly. Yeah, no, with Knative, you have your ISTIO ingress controller. And so we actually do, because OpenFaaS didn't even have any sort of auth layer. It does now, but so we put our own ingress controller with auth that then goes to the gateway, which then goes to the function. So you add that kind of hop by having an ingress controller, but you can absolutely use one. And we had to get the extra features. But I mean, at the end of the day, the gateway really is just a web server. It's calling functions for you.
Yeah, you have more flexibility. Like if you're already using, let's say, ingress Nginx or something like that, that's already a place that you want to start adding OpenFaaS that you don't have to switch it before.
Right, you don't have to have it. Yeah, and that was a huge deal for us too, because we already had this whole ingress plot. Like we did ingress for forever. We didn't want to switch. I didn't want the heavy lift of getting a service mesh. Just didn't want to deal with it. So you're right. If you already got ingress going, then installing OpenFaaS really is like sticking things in there, making ingress role, start using it. Yeah.
Now, what makes you pick, a platform like this versus building like an opinionated Domo, kind of functions as a service?
Time. I don't want to, for like the number of ops people, the dev people at Domo is really skewed. There are very few ops people, and I just wanted to do something that would work most of the way.
So your dev's pretty polyglot, so there's not like a good standardization.
No,
you can be opinionated.
We may get there. We're moving more and more things to functions. We're looking at moving a lot of our really bursty small load out of old systems into functions, and so we may have to be more opinionated about that. I think the only opinion we have so far is we're using the operator in OpenFaaS. We're going to say, don't talk to the gateway to do admin stuff, only need Kubernetes resources. But that's mostly because we have a lot of different OpenFaaS installations, and we do blue and green cluster upgrades. It's a lot easier to rip out the function custom resources and just drop them into the next cluster than to recreate the API calls that went to OpenFaaS. But that's like the only opinion I have. Outside of that, I've just been letting it evolve and see where we're going with it. Like I said, we're just really starting to dive into it now. We've been using it for a while, but now we're really hitting it.
Is this just for developers?
No, it's because we have some workloads that just fit so much better in function than part of this. I don't know what you want to say, but part of this is the way the Domo architecture is structured. It's not as easy to make services as it should be. Making a new Domo microservice, micro being not that micro, is huge lift. And so it's resulted in a lot of services doing more than they should because the kind of the wall you have to get over to make another one is too big. And the footprint, the way we deploy our services, the footprint for any service is much larger than it should be. And so we're saying, okay, well, look at all these services that have written things that could be and should be functions to. They're very discrete bits of calculation or logic. And so, and a lot of times they need to burst really quickly. And so what we do is just scale that service up to a lot of machines and have it go and use most of the time. So we're trying to really like focus in on our costs and just move the things that don't belong in the service catalog. Yeah.
So depending on the application though, but why is the typical depth of potential nested function? Like if you have one more layer of series kind of function, right? So you say,
Oh, you're talking about where you have ingress in front of the gateway, or?
When developer dealt with this kind of particular function, let's say internally there, they may call another function as service.
Oh.
And then another, so why is the typical, depends on the application type.
Right.
Have you seen that kind of some gaps there, or typically just one?
No, I think it depends on what you're doing. A lot of times it's one, but imagine like you've got a S3 bucket, and every time someone drops a file in that S3 bucket, an image, you want to take that image and convert it to a different format or resize it. That is a function, right? You say, watch this bucket. Every time an object comes in that looks like this, take it down, reformat it. But that's a function. What people tend to do after that, if you haven't done functions much, is say, okay, after I write that, I'm going to write another part lower down in that same code that sends a message to my chat system that says, hey, somebody just uploaded an image and here's the URL, or sends a notification to another service that says, here's how you get the converted image, right? And that's not really what you really want. You want that function to be the convert image function. And so the pattern is, you'll write a thing and you'll write the thing and inevitably you say, okay, do this one thing and then tell another function to call now against that so that it has its discrete logic for the next thing.
So do you think that functions should not have their own data store? I mean, how are you connected to it? How are you going to,
right.
This is more calculation, it's more do something that passes on to somebody else rather than.
Well, connection pool is a special case that depends on the platform, right? So in Lambda, that's the reason one reason you'd write your own Bootstrap script that sits next to your function is because that Bootstrap script has the ability to set up a connection pool and use it. Because that can be that's a big thing that a lot of people run into is they're like, I'm going to move this function, this logic over to a function in Lambda, and it's going to hit a database and query for a user, and then you have 10,000 database connections because the function's running 10,000 times. So that's, in that case, yeah, there is some stake. But other than that, I would say no, this happens to us a lot, keep the function as small as you can, with as little as, the connection pool is one such case, mostly don't give it any stake. Let it do the thing, throw it out to a different place where there's state, right? So another queue somewhere, which will then potentially call another function or series of functions. And it's hard. In practice, it's really hard because you're like, no matter how easy it is to make a new function, you're like, but I can just put the one line here that sends a message to Slack. I just put it here in this function, and it would work, and it would work. But you have to force yourself to follow the pattern. Sort of like when you switch to containers or Kubernetes from the old system, if you don't work with the pattern, you're gonna get something that's worse than we had before, not as good as it could be. We find ourselves doing that. I have to tell my coworker, and he has to tell me no, that should be its own function, move it out.
I think that's a lot. I've seen a lot of architecture, Lambda and other things. They try to do more than a function.
Yeah.
It's more what a service is, and it is sources. It is too much.
Right, and then that's when they start to go past their limits of runtime. It's it's not just doing one thing; it's doing a bunch of junk. Sometimes it's inevitable. Sometimes you just have to look at should we really be doing this, or should we split it out somehow? If you can, yeah.
So I was going to ask, what's your philosophy or your practice at the Domo where you're learning? So I believe one of the benefits of OpenFaaS is there's still a Docker file, and you basically call your function from the Docker file, your Docker build, your image, right?
Yep.
Are you having the developers create and manage these Docker files? Or is that something that they're handing over to you and say to your other ops?
That's something we're still figuring out. Because right now the developers are managing those, and the idea is that we just validate the images. We don't really care how they're built. But that's something I think is a lot of times glossed over, and we've had so few functions that we haven't quite had to solve that yet.
Okay.
But yeah,
I was just wondering if you guys, you had any, feedback.
Any like good patterns or any of that stuff. Yeah, no,
It's better having them do it, or it's better having like handle it ops versus.
Right. I think it's better to have them do it. That's the point of the container, right? Like, you kind of have to solidify your container build pipelines to make sure we're all not building off untagged versions of operating systems or old versions or whatever. Like, you have to solve some of those problems, but at the end of the day, like, with your function, I really don't care what the language is or how you built it. If we can get the code and validate it. Security people would hate that because they want to like really scrutinize it all. Mostly operationally, I'm like, well, you test your function, I'll put it out there.
Yeah.
Yeah, we don't have any good patterns on that.
You can always manage that like a later security layer level too, like with like a system like security monitoring like that, where like, you're using an image that base image that
they don't trust
as an ops team or something.
Yeah, I think
later on.
I think we're not doing it yet, but I think inevitably we're going to end up moving to like requiring signed images everywhere, which is a huge pain to actually do in reality. But I think we're going to have to go there because there's a lot of bad practice with Docker. Like I wish Docker files were more opinionated about things because there's so much bad practice out there about building Docker files. And, like we kind of had this. If anybody went to the it was your talk. What was the build system? Bazel, yeah. Like when you look at Bazel, like we built this because Docker files aren't really repeatable builds. They mostly work, but if you don't build them exactly right, they're not super repeatable, right? So yeah, I think it's really hard to police your developers' Docker usage. Yeah.
So one of the odd things that Lambda supports is persistent global state.
Okay.
I'm guessing that because both these frameworks are Kubernetes, that they just decided not to support that by any means.
Yeah, no, I don't have anything with that. So, but I mean, that's the advantage of being in a big, being in Lambda and having all the AWS stuff is they can be really fancy for you on the back end, right? But yeah, they don't have any of that. It's all just super hyper stateless. I was going to see if I can find the Docker file because it is in here. It's not complicated. Build tags file. Yeah. So, and I didn't build this, right? This gives you an example of the OpenFaaS Python template where they've got some opinionated stuff just in OpenFaaS itself because they're saying here's a Python 2 point whatever or 3 point whatever template that you build your function in, and you can use your own Docker file, but also you can just write the code and we'll inject it for you. And then they've got a lot of stuff here that I don't have to write that is clearly the best way they think it's possible to do.
So this was your Docker file your demo here?
For the get tags function. But I didn't write it. I said fast CLI, generate new Python my tags. And then it didn't even build this. Like actually when I generated that, we can do it now.
There was an OpenFaaS specific image though that you referenced though. That was in the multi-stage file, was it? I didn't see another from stage.
No, I think they're building it on Python 2.7.
Okay.
Yeah, I don't see another from in here either. But again, this is the OpenFaaS specific one, but I have to write it. What's that?
For somebody who taught security, you thought there's something that you said.
I know. Well, yeah, I know. Well, I don't use it in my solution. I don't use Python at all. I don't have to. So let's do it. I'll show you again because it's pretty cool. We do the fast CLI, generate. So there's tons of stuff in there. I'm going to call it. There's a lot of options in here. What was it that I ran in the demo? I guess it's not a demo. Oh, hold on. That may not be. It's not generated. It is CLI new. My bad. Generate is for generating Kubernetes YAML definitions.
So it's CRD.
Yeah, that's what I was like. That doesn't seem right. I think my slide may be wrong on that. New. Sure, we'll call it chatbot. Let's do the exact example. No, I don't know anything about Node. Nothing. But I built it. I did generate. Now I have this new chatbot directory. Inside there, there's my handler.js, and you know nothing about Node. I guess that I should go put my logic somewhere in here. And it has a package.json, which I do know is where you define your stuff in Node. I'm mostly a Go programmer. But then it also made this chatbot YAML for me. And if I do a OpenFaaS build-f on the chatbot YAML, OpenFaaS CLI, right? It's going to go get the Docker file that is for the Node template that I'm using. This is that whole template list I showed you is a giant list. Like somebody, like the OpenFaaS community has already said, this is how we build a Node image, and I didn't have to know the best practice or even the tools. I just wrote the actual minimal code, which I think where it starts to shine is like those helpers for me are super great to not have to worry about the details. You can use your own Docker file if you want to modify it, but if you don't need to, let them handle it. So that gives you kind of an idea of some of the power of that tool.
So it's like wrapping like Docker build.
Yeah, wrapping, creating files in Docker build and calling the gateway, and like that's a pretty useful utility.
Yeah.
But you can absolutely in that if I cancel out of this in that chatbot YAML, there's more options in here. Not only laying handler, but you could say here's the Docker file that you should use instead of getting the one for the default one for the language. Right? There's a whole mess of options that you can put into that file, including this is where you'd say what the resource constraints are, what the scaling constraints are. A lot of that goes either in here, if you're going to call the FaaS gateway directly, or use FaaS CLI, or something like this in a Kubernetes document.
Yeah, so like, and I see that it's doing like the whole tagging like namespace situation with the image or just chatbot betas. Like, what if you wanted to like store your images like in a registry somewhere else? How would that? You just manually go in there.
Yeah, and it just yeah. You could just say registry and it would work. It really is just like where do I put the Docker?
It's giving you like a template. You just tweak it.
Exactly. Yeah. This is just like minimal get going.
Yeah.
So if you want to HTTPS, you don't certain management.
For FaaS gateway?
Yeah.
Yeah, we do that in our ingress controller with. We are still old school, so we're still using what was the original Kubernetes?
Lego?
What's that?
Lego.
Yeah, Lego. We're still using Lego. We haven't switched to Cert Manager. We're not cool yet. But we, that just generates some SSL certs and do it at the gateway.
You're doing it at the gateway. You can actually do all the functions.
I have no idea. That is a really good question. I don't know if they've solved for that. I think it's kind of a dirty Kubernetes secret is we all do encryption at the edge and then just pretend the rest is safe. Unless you're using service mesh, you can do the encryption with the service mesh and it's done free. Or a lot of the networking layers now will do encryption for you just between, it doesn't really help you if you execute the pod and have like tools to sniff traffic, but it will help you for just going over the wire.
Is it like upgraded certificate option as well?
Yeah, maybe. The
I
new
know you can use let's encrypt certificates free plans, but I thought they were giving like an upgraded option that you want like a 1 year extension or 2 year expiration or after.
There's probably some fancier ones. I'm a big fan of Let's Encrypt, so we still use that for most things, but it does come with its limits, right? So you can't live within those. But yeah, I mean, the short answer is OpenFaaS. The encryption is the encryption, at least at the edge, is whatever Ingress controller does. It's completely separate. Maybe the gateway could do encryption. Again, I have not dug into it. There probably is. There's probably a way to tell the gateway process, which is a Golang web server, to do TLS, but we have to solve for that. But the functions would be the big one, right? It probably would be hard because the OpenFaaS Watchdog is it's like a standard web server that all your functions use. So if that has some way to support encryption, The problem is generating like this search for every function in the pod. And, yeah, it's all the same problems. I wonder what actually what the let's run the generate command. That won't work, but I'll choose the animal it brings. So we generated a new function which gave us a YAML file that we could send straight to OpenFaaS. But I think you can also, yeah, there you go. So you can generate a function declaration to send if you're using the controller that we didn't put much information in. Like it doesn't need all the same options that we need for building the function. So it just rips some of the stuff out, but it would convert it to the spec for you. So it makes it pretty easy. Again, just showing that they've thought through like what is the end user experience like. And if I've got this FaaS YAML that I've been using to call straight to the gateway and I want to start using their operator, here's a function that turns that into a custom resource for you. Kind of stuff. I think that kind of stuff really shows the building an end-to-end solution. Anybody else? Cool.
As usual, I'm sure what's going on, private conversation, whatever.
The talk in August will be really cool. I'm really, really proud of that one. If you haven't done it, it's an operators talk, but an operators talk about like practically like it's a contrived example, but at least we're building something and seeing why an operator is important and why it's better than YAML, why it's better than Helm instead of just telling you it is. Like I deploy a thing and I explain why doing it with YAML sucks, and then we make 3 kinds of an operator in the talk. So
yeah, so that'll be a good one. And then as I say in July, kind of a grab bag, best practices tips. I'll be soliciting that type of information through the Slack channel. But we have another Jabrain thing. Who has already had one? Nobody. All right, we go by birthdays. Let's see. Let's go a couple times. Let's see. April. Oh, come on. I guess first time. Man. First time. 9 is September. Whoa, this is a good generator tonight. Yeah. Way to go, man. July. Yeah. Oh, okay. There you go. Wait, how many? We got 4? That is a first, right? Let's see, 31. Let's see if we do that one. Okay. We'll go closest to 1, either up or down. Okay. 18. 8. 3rd. 13. Oh, 13.
Number 10, which is students game.
13 wins. Way to go.